Hello. So now we continue our discussion with the linear regulators, and we have seen the working principle of standard regulators and low dropout regulators. We've also seen what regulators choose when. Now in this slide, you can see I'm going to explain the protection circuits in IC, integrated circuits linear regulators. So whenever you will buy a linear regulator IC, whether a standard regulator or a low dropout voltage regulators, inbuilt there would be some circuitries. They are called as protection circuitries. Now, why do you need them? That's the first question. So imagine you have an excessive load current that is connected to, you are connecting the regulator to the load, and this load current is being drawn by the load right here. So if there is a very heavy load current beyond its specified rating, so you need to control that and limit it to a sufficient value to avoid the damage to the regulator or to the load. So first circuitry for that. And the second circuitry, within the regulator, you can have excessive higher operating temperature, irrespective of its cause. So to avoid the damage to the regulator from excessive heat, you need another protection circuitry. So there are two types of circuits available for the regulators. One is called as thermal shutdown, and second is a current limit. So we are going to explain the details of it as in the subsequent modules. So currently we are just trying to understand what these circuits are and why are they needed and what they do. So essentially in the regulator IC, within the regulator IC integrated circuit, you will have a three control groups. First is a voltage error amplifier. We have seen that in the previous model. You have an error amplifier actually, and that voltage error amplifier generates an output depending on the inputs to it. So that is the first loop, feedback loop, control loop. Second is due to the thermal protection circuit. Third loop would be a loop due to the current limit circuit. So all these circuits will be inside the regulator ICs, and they will generate the feedback based on the output. And accordingly, they will ask the regulator circuitry inside to take appropriate action to limit the damage to the regulator by controlling the load current and by controlling the operating temperature. So out of these three loops, the voltage control will take the lead always, and it will assume, when it does so, it assumes that both the load current and the junction temperatures are below their threshold values. So it is assuming that where regulator IC is working properly, it is delivering the proper load current to the load, and the temperature within the IC is also under control, and your regulator with the voltage control group is functioning properly and maintaining the constant output voltage across the load. If the load current increases to a limiting value, the current limiting circuit then will take control and force the load current to set to the set limiting value, overriding the voltage. Okay, and the voltage error amplifier after that can resume the control only if the load current is reduced sufficiently to cause the current limiting circuit to release its control. So once the current limiting circuit is active, it reduces the load current to a limiting value, and again the voltage control circuitry takes the hold in the circuitry. Now there is a case that there is a rise in the temperature of the IC. You have an IC integrated circuit and the temperature goes up, and it can go up to plus 160 degrees centigrade. Okay, regardless of the cause, any cause can be there, and this will approach the limit threshold above 160 degrees centigrade. This will cause the thermal shutdown, and thermal shutdown means your regulator circuit will cut dry to the power transistor. Remember, refer to the previous video. There is a power transistor that delivers the load current. So it will cut the dry to the power transistor, thereby it will reduce the load current and subsequently internal power dissipation. And in the current limiting circuitry, the output voltage will be reduced. So you have, let's say, you have this output voltage VO. So suddenly your output voltage will go down, okay? And the current limiting circuitry as required to hold the load current at the set limiting value, okay? And in the thermal limiting, the output voltage also drops. In the thermal limiting, the output voltage also drops, and the load current can be reduced to any value including zero. Okay, the load current, for example, can be reduced accordingly, and it can go to the any value up to zero. So that was the basic about the control circuitries, or called as protection circuitries in the IC linear regulators. Now we will explain one by one the working principle of the thermal shutdown protection circuit and the current limiting protection circuit, how they work. Okay, so hope you found this video useful. If you do so, stay tuned, subscribe to the channel for upcoming video content, and refer it to others, share it with widely. Wish you happy learning.